So we do have our quiz today. We're recording this for the people that are not here so they can watch this lecture at home. So let's do it just to remind you on what's going to be on your quiz. Are you ready? The first couple things you have are elements, compounds, homogeneous, and heterogeneous mixtures, correct? Let's go through and make sure we all remember that. Elements are found where? On periodic table. If it's off of there, it is immediately an element. You're going to notice it because it has a chemical symbol, right? It says it cannot be separated into simpler substances. Compounds are a combination of two or more things in a fixed ratio of elements. Okay? Now, if it is not an element and it is not a compound, then that means it's a mixture. Homogeneous and heterogeneous mixtures. Which one looks all the same? Homogeneous. And I try to make it on our examples on our quiz that it is very straightforward. Okay? Heterogeneous, you can see the different pieces and parts in the mixture. We said like trail mix or pizza, things like that. All right, then the other two that we talked about were intensive and extensive properties. I want you to think about if I have 1 or 100 of them, does that property change? For instance, like mass. If I have 1 penny or 100 pennies, does the mass change if I were to put them on a scale? Yes, so that is extensive because it does depend. Intensive would be like color. If I have 1 or 100 pennies, does the color of the pennies change? No. Intensive. The last thing that we talked about there were physical and chemical changes and physical and chemical properties. A physical change, nothing new is made. And a chemical change is irreversible and you have new things made. Okay? Does anybody in here have any questions on these items? We learned this last week in your mini quizzes today. If I happen to leave this up here, okay, I want you to make sure you utilize this. Now, we do have our test on Friday. You will not get this on your test on Friday, but if this stays up here for today, just saying, this is your check for understanding. The other thing about the matter quiz is a lot of people are like, can I abbreviate? And I'm like, yes, please go ahead and abbreviate. But if you are like, I forget if it's intensive or extensive, so I'm going to write an I, like, I don't, this, X, and some. Okay, make it nice and clear, okay, what you're trying to write. On my mixtures, I try to make them very clear, like cheese is all like yellow, or it's all like just white, right? Black coffee, just black coffee. So I tried to make them very clear on your quiz. If you have questions, please don't hesitate to ask me. Okay? Awesome. So what we're going to do is we're going to get into this quiz. You're going to make sure you're doing that. Then you're going to turn in the A and B folder, and then we will have our last set of notes today because our test is Friday. Our last set of notes are today. When you're done, turn it in the A and B folder. If you do what you do, this is that stuff.
Oh, good. Perfect.
Yeah. Notes for the unit. Last set of notes. So go ahead wherever your note packet is, find it, and get her on out for me. Let's do it. All right. Okay. So here we go. So we're gonna, I don't like the order of this worksheet. I'm probably gonna kind of flip-flop a little bit in here. So make sure you're out, put your phones down. You had plenty of time with your phones. Now it's time for chemistry. The first thing I want you to do, and so I know this is a little out of order, is flip it to the back where the picture of the candles are. We're going to talk about this little law here at the very end, and we're going to do another demonstration before it, but I'd like to know what you think happens to the mass of a candle as it burns. And so what I have up here is I have a candle, and there is a mass. Maybe, Peter, will you come up here real fast? And will you tell everybody the mass? Come on up here real fast. It's going to make you get it. Yeah, you come on. You can do it. Will you tell me the mass of this candle? I don't want anybody thinking I messed with it. I want you to read it for me. What does that say? 78.32. Awesome. All right, you can have a seat. I'll call you back up in a few minutes. I thought you needed, like you wanted, you know, blood pumping. What I'm going to do is I'm going to take it and I'm going to light it. And then I'm going to let it burn while we have our conversation today. And I want you to pick one. And I want you to tell me, what do you think is going to happen? Is the mass going to increase, decrease, or stay the same when I take the mass again? Excuse me. When Peter takes the mass again in about 15 minutes. So give it a circle. Let's see if you can get it right. Interested to know. Okay. Yeah. Yeah. Oh, if anything spills off, it'll make it. All right, so that is that. We're going to come back to that. So go back to the front page. We'll start all over again at the front. We'll get back to that when we get back to that. One of the things I found that sometimes students have a little bit of a problem with is when I start talking about solutions versus liquid, and then once we start getting into some chemical reactions, what the word aqueous means. So I want to take just a moment. This is just a sound bite. Liquids, in a chemical equation, you'll see it as a little L. Liquids, represented with an L, are simply a pure substance. For instance, like water, ethanol, oil, mercury. If I take a nail and I melt it, that's liquid iron. So not all solutions are liquids. Okay? Those are just pure distilled water. That is a liquid. What we're going to deal with most in our life, we don't deal with a lot of liquids in life. What we deal with are called solutions. And solutions are, it says, a homogeneous mixture of dissolved ions. I understand you probably don't know what ions are, but you know what homogeneous, like this is a solution up here. Can you see any of the materials that I put in this water? No, it's a solution. It's a homogeneous mixture of dissolved ions. Now, the thing about solutions is more often than not, you make them in water. And if they are in water, you tell somebody by saying an aqueous solution, which the little symbol is an AQ for aqueous. An aqueous solution is just simply a water-based solution. So most of the solutions we deal with in this class are aqueous solutions because they're made in water. Now, you can have oil-based solutions, alcohol-based solutions. You can have different bases to your solutions, but for most part, all of our solutions are going to be water-based, okay? AQ, you got it. Now, I'm actually going to jump down to the bottom. Like I said, I think I'm going to change the order of this because as I was looking at it before class, I was like, you want to know what? So let's do this experiment first. What I have up here is some magnesium sulfate, the same thing we did yesterday. So if you weren't here yesterday, you're going to watch it again. Magnesium sulfate, write the little AQ. That is an AQ. That is an aqueous solution. When you write parts of a reaction, this little plus sign means it reacts with sodium hydroxide, which is also aqueous. It's a little AQ. So what I'm going to do is I'm going to react these together in 1 second. But I just want you to know, when they are your starting materials, they are called your reactants. They are called your reactants. Okay, so I'm going to put on my good little goggles here. And so I'm going to pour a little bit of this. Good stuff. We got some magnesium sulfate, and I'm going to hit it with some sodium hydroxide. So we both have, oh, I'm sorry, well, that was sodium hydroxide. These are both clear, colorless solutions, and boom. All of a sudden now I have made a white precipitate. This is a solid in solution. It is a white chunky precipitate just like we made yesterday. Okay. This is a solid. The white precipitate is a solid. And then the sodium sulfate that's left in there is aqueous as well. So this was the chemical reaction that just happened. 2 more things you have to know. This arrow sign means to yield. So you would say magnesium sulfate and sodium hydroxide yields. And then what they're called when you are finished are called your products. Magnesium hydroxide and sodium sulfate. They did a little switcheroo. You'll have to be able to know that some other time. But what happened was the magnesium went with the hydroxide and the sodium went with the sulfate. Okay, so they did a little switcherooskies. I will guarantee you that these terms are going to be on the test because when we go to balance equations and I say, hey, how many oxygen are in your reactants? And you're like, I don't know. Is that the first ones or the second one? Just so you know, we will have these things on the test on Friday, okay? So now let's go back up. Now that we did this little portion here, and this is kind of a little bit of a review today. This white solid is called a precipitate. Remember that they are solids formed in solutions. Precipitates are solids formed in solutions. And if they are solids in solutions and they didn't dissolve, that means that they are insoluble. Because if it was soluble, it would have just dissolved away and you never would have saw the precipitate. So thinking about yesterday, this is a solid in my solution. Talk to me, what's one thing I could do? Awesome. Solids in solutions, you could filter it. There is one other thing I could do to this, and it's white, so I can't do chromatography. Centrifuge, very good. The two things I could do, I wouldn't want to distill it because I wouldn't want to boil it and risk burning it. But because it is insoluble, that means that I can use filtering and I can use centrifuge to get my solid white precipitate out of here. Because, and this is what you just did today, because I made a solid and because it turned from clear to white, do you think this is a chemical or a physical change? That is very nice. A chemical change. We made something new, a solid form. There was a color change and all that kind of good stuff. Okay. Awesome. So again, we're just reviewing some of these terms. Remember, solubility is just the ability to dissolve. Things that are soluble can dissolve. Things that are insoluble cannot dissolve. So at the end of the day, is that solid precipitate soluble? No. Okay? They did not go into that solution. So that precipitate, that solid, is insoluble. And what that solid is right here, magnesium hydroxide. Now, would you want to drink this glass of goodness right here? You're like, yes. Some people say yes. So we said that this is magnesium hydroxide. And who can I pick on? I'm picking on people in the front here today. Has anybody ever seen this product in the store? It's called Milk with Magnesia. Yeah. Okay, yes. So let's see. I'm going to pick on you. Right on here on the top, it says active ingredients. Can you tell me what that is? Hydroxide. Magnesium hydroxide, this active ingredient is the exact same thing that I just made up here. Not looking delicious. Now, the only reason why I point this out is, number one, most of the things you buy in a pharmacy are just straight up chemicals. I mean, everything is a chemical, but some of these need to be regulated. You got to be careful. You don't want to take too much of this. But the other thing I like to point out just very quickly here, if you're like, hey, I want to go into business and I don't really care about chemistry, bleh, there's so much in business that has to do with chemistry. Would a person that was purchasing magnesium hydroxide, if they were ill, want to buy something that said magnesium hydroxide on it? No. But what if you said, this is milk of magnesia? Does that sound much more calming? That sounds nice, right? And this is a solid that is insoluble, so this is the one I made yesterday. Over time, that active ingredient is going to settle out to the bottom, right? Does that look like something you would want to drink if you're looking at the grocery store? You're like, that? Is that why you think you can't see through this bottle? So when it sits a long time on the shelf, the active ingredient is on the bottom, and then the rest of the liquid's on the top. What's the other thing? The first thing you need to do in the instructions here, it says shake well. Why do you think this says shake well? Talk to me. Perfect. Your active ingredient is down here, and up here is all the extra leftover stuff. If you don't shake this and you just pour this and look, are you getting any of the medicine here? No. So you would think in this one little bottle, like, why does it look like this? It's all driven by chemistry. The name of it is driven by chemistry. The color of it is driven by chemistry. The instructions on it are driven by chemistry. So if you're like, hey, I'm going to business, I don't need chemistry. It's there. Chemistry is everywhere. Okay? So just a little fun fact on the day. All right. Let's get into it. We're on to the next page. Oh, goodness, I'm making a mess of things. That's okay. I'm going to do this reaction one more time. This is a triple beam balance. And I'm, though, going to take the mass of my reaction before and after. Where are my Google-Os while I pour this stuff? I'm going to pour a little bit of this in here. I'm going to pour a little bit of this one in here. So we're going to do the exact same reaction we've been doing like 25 times now. Now, I need your help trying to get me to make this. This is a triple beam balance, so everybody can see. When this is balanced, these two lines are going to meet up. Okay? You can see over here? These two lines are going to meet up. Are the lines exactly on each other right here? Is it below or above it? This line and this line. Below it? Okay. Let me add a... oh, that's too far now. Oh, heavens to that ceiling. Still below it. Now below it. Now it's above it. Oh, too much. All right, we're getting closer. We're getting closer. Oh, of course, we're like right on the edge there. Too much. Too little. All right. How does that line look? About right? Oh, right enough, right? Okay. So now I have it lined up. The mass of this is 270.7 grams. Now, I'm going to do this reaction one more time. I'm taking an aqueous solution and an aqueous solution. I'm making a solid in an aqueous solution. When I react those together, do you think the mass is going to increase, decrease, or stay the same? I'm going to make a solid in solution, increase, decrease, or stay the same when I do this reaction. Give me a guess. What do you think? Do you think it's going to stay the same? Anybody think anything else? Nobody wants to share. Okay, I'm here with it. All right, so I'm going to take this beaker, two liquids. I'm going to pour them together. I'm going to make a liquid and a solid. Ready? And... all right, the mass went down. What am I forgetting? Oh, okay. The mass should be exactly the same. The mass is exactly the same. If you did that, good job. If not, circle it up. The mass stays the same. Why? Where did all the molecules come to make that? Where did they come from? The beaker that was already there. Did I add anything new on there? Did I take anything off of there? This is the new idea here. The law of conservation of mass. Write it nice and big. I got a great test question on this one. Ooh, it's so good. Matter cannot be created or destroyed. You might have heard that before. Matter cannot be created or destroyed. The only thing it can do is it can change forms. It can turn into a solid, it can turn into a solution, it can turn into, you can move things around, but you cannot create or destroy matter. Now, does anyone want to change their answer on their candle? Are you feeling extra confident on the candle? Matter cannot be created or destroyed. What was the number on the front of your paper? I'm sorry, 78.32? 78.32. That's already the one you have there. Yeah? Who thinks that the mass should still be 78.32? Who thinks the mass should be smaller than 78.32? Who thinks it should be larger than 78.32? Feeling good? Matter can't be created or destroyed. Yeah? Come on up here. I didn't do anything to you. I want you to tell me what the mass of it is. 70, a whole gram. Very nice. 77.3. What happened? The mass went down. Oh my God, did we just break the law of conservation of mass? Why? Where did it go? And where did that go? Into the air. Where do parts of the candle go? They go into the air. Okay? Have you ever burned a candle for a very long time? Does it eventually go away? You can't burn it for your whole little life and be like, I've had this candle since I was 4. Like, it doesn't work like that. You burn it and it goes somewhere. Where does it go? It goes into the air. And then you what? And you can smell it, exactly. Something came into it. I got a non-scented one for you here. So this is, and we're going to skip this bottom MSDS part. I don't want to do that anymore. But so this is a huge idea. And what I want to show you here is a little lab you can do. Oh, sorry, you at home can't see this because you wouldn't be able to do it anyways. I guess maybe I can show the people at home. To prove to you that you are losing stuff from your candle, what we're going to do today, and this is a little trick, again, you can do it at home. I'm going to give you a little splint. In the years before COVID, I let people just blow the candle out, but I, this morning at 6:30 in the morning, thought, oh my God, what if I took a spoon and covered it in aluminum foil? So this is going to be your tamper. You're going to tamp it out. And what happens is the gas that is released from the candle once you tamp it down or blow it out is actually flammable wax. And what this person is going to do is they're going to take their splint and they're going to light that white vapor, and it will chase it back down, and it will actually relight this candle. Now, this one's in slow motion. I'm going to see if you guys can't do this here in a second. Let's see. So you're going to tamp it out with a spoon, and then you're going to try to light this white gas on fire, and it will go back down, and it should relight your candle. Okay? So what I want everybody to do is we're going to turn the, we'll watch one more time, slow-mo. Ooh, I love some slow-mo. So this is actually just vaporized wax from your candle. It is absolutely flammable, and it's kind of hard to get. You got to chase it with your splint, but if you can get your lit splint, so make sure you light it before you blow it out, get your lit splint to light that gas, and the more that you get better at it, the further away you can get. It will actually catch it on fire, and then it will relight that candle wick, okay? So we're going to turn the light back on.